So again, today our objective is to learn and apply properties of proportions. This comes out of lesson 8-2, oh, sorry, 7-2, Algebras in chapter 8, in 7-2. Okay, so yesterday we had ended with talking about proportions, and we had labeled them A over B equals C over D, and we labeled them this way. This is the first term, second term, third term, fourth term. You guys remember that from yesterday's notes? Okay. Well, we're going to give them new names, and we're going to group them together. Okay. So if we're going to look at the first number and the last number in the proportion, so if we're going to look on this diagonal, we are going to call those guys the extremes. That's the first and fourth, or you could say last, terms in a proportion. Okay, so first and fourth or last terms in a proportion are called extremes. Okay, so let's group the other two terms, and their name is the means. So the means are the second and third terms in a proportion. Okay? And understanding that is going to help us understand our first property that we get. And remember, properties are theorem cards. They go underneath there, and we use them in our proofs and also solving problems. So the first one is called, has two names. Its first name is called the cross product property of proportions. Okay. And the cross product property, that doesn't look real good, does it? Of proportions states this. If you have this proportion, A over B, equals C over D, this is equivalent to, or we could say is the same as, the cross products, which would be AD equals CB. Or let's write a BC. It doesn't really matter, to be honest with you, because of the commutative property of multiplication. Okay, so A times D is going to have the same value as B times C. So link it back to the words before. This is sometimes referred to as the means extremes property. And again, if we look at what we have, we've got the product of extremes. That's your first and third, that's your A and D, is equal to the product of your means. So some people, again, call this the means extremes property, because that's what you're doing. Matthew, do you have a question? Okay. All right, so let's talk about a couple other properties. Shh. Shh. We have the reciprocal property of proportion. And we'll start with our proportion. If A over B is equal to C over D, then their reciprocals would also be equal to each other. So B over A is equal to D over C. Okay, so remember reciprocal. A over B and B over A are reciprocals. What do you get when you multiply reciprocals? Pardon me? You get 1. Yeah. Anytime you multiply reciprocals, you get 1. That's what the inverse property of multiplication talks about. All right, so then we kind of have all these other properties. We weren't exactly sure how to deal with them, so we're going to shove them all together into one generic other properties of proportions. Thank you. And this one says if A over B equals C over D, gentlemen, then we've got a couple things that we can conclude. First, we could conclude that A over C is equal to B over D. So what did they do to our original proportion to get this proportion in A? Yeah, so if you just, all they did was take these two guys and swap spots. Okay, so that was part A. And then part B says, if I add the denominator to the numerator, then it would be the same if I added the denominator to the numerator on the other side. Okay, and let's kind of analyze why this is true. I have a single denominator, so what I can do is create little mini fractions. So if I wanted to, I would get A over B plus B over B. And then we would say that that's going to be equal to C over D plus D over D. What's B over B equal to? And what's D over D equal to? So if I subtracted 1 from both sides, these would cancel out, and you would be back to A over B equals C over D. Okay, so there's a mathematical reason why that works. Okay, all right, and then I have another one. Let's see if I can. But it doesn't go with that if statement because that only is a proportion. Remember we talked the last vocab word yesterday was extended proportion? Well, this deals with that notion of an extended proportion. So this one says, okay, well, if A over B equals C over D equals E over F. Somebody's phone is going off. Then I can add all the numerators and put them over all of the denominators. Okay? So it's saying the relationship, if I have all those proportions that are equal to each other in that extended proportion, then that's going to be, I am going to get the same, or this value, I can take all those numerators and add them, take all the denominators and add them and put them together in that ratio. And I'm basically not going to change any of the values. Okay? So a lot of what we're going to do with this information is we're going to be solving some problems. So I'm going to give you some examples. I've got a couple of them for you. So when you're ready. All right, so let's do some examples of how we might use these. So the first one, use the proportion x over y equals 5 over 2 to complete each statement. So use the proportion x over y equals 5 over 2 to complete each statement. 5y equals, and we got to fill in the box. So what we do is we look at the original statement and go, well, where did 5y come from? Say again? Yeah. They did cross product. So if they're going to multiply 5 times y, our answer is going to have us multiply x times 2. And so what would go in the blank would be 2x. Okay? So I'm going to erase everything and then write back in the 2x. Okay? And then b. Oops, sorry. X plus y over y would equal what? So think about what property would allow me to deal with this one and what would go into the blank spot. Dakota.
5 plus 2 over 2 or 7.
Oops, sorry. Let me get a color in there. So if you go back to the other properties of proportions, part B, we would say if I add the denominator to the numerator, keep it over the denominator, the value stays the same. Okay, because I'm literally just adding 1 on each side that I can eventually get rid of. Rachel.
For that one, would you just leave it 5 plus 2, or would you like simplify it?
You would first start there because that's what it looks like. And then you could take it one step further. And you could say that that is 7 over 2. But again, 7 over 2 would not, for most people, they wouldn't understand where the 7 came from. So there would be that intermediate 5 plus 2 over 2. Okay? All right, let me give you another one. What if I give you 2 over 5? Which of our properties deals with that? If we had x over y equals 5 over 2, what do we know that 2 over 5 has to be equal to? And we've got y over x. And that's going to be the reciprocal property of proportions. Okay. And then D, we've got x over 5 equals, and then what's going to go in that spot? And what tells us we can do that? So what's going to go with the x over 5? Josiah? Y over 2. And if you look at our properties, that was under the other properties of proportions where we just kind of swapped places here between our means. Okay? All right, so that's example 1. Let's do another one. You're going to have a diagram. Triangle ABC. And then we've got this segment DE. And you're going to be given that segment AD over segment DB is equal to segment CE over segment EB. So AD is the hypotenuse, DB is the lower portion of it, CE is the long leg, EB is the longer portion of it. So if the length of CE is 2, the length of EB equals 6, the length of AD equals 3, what is the length of DB? So I'm looking back to what I was given originally. And CE is here, EB is here, AD is here, and DB is what I'm solving for. So they gave me everything I needed in the proportion. I'm just going to plug the numbers in and solve. So that gives me AD is 3. DB is what we're solving for, so I just leave them as DB. CE is 2, and EB is 6. So I'm going to use that cross product property of proportions, and that gives me 2DB is equal to 18, divide by 2, and we get the length of DB equals 9. Okay? So all these properties in play. All right, I've got another one. Let's see if I have enough space for it. Okay, let's do over here. Or, I'll just go to the next page. I'm going to go to the next page, and I'm going to replicate that diagram. Okay. So, using that same diagram, A, B, C, D, E, and we've got AB, or AD is, sorry, AD is to DB, as CE is to EB. So that's all of our given. What if we're told that if the length of AB is 10, the length of DB is 8, and the length of CB is 7.5, what is EB? So this kind of goes back to one somebody asked me from last night's homework. When I'm looking at what they gave me, I don't have AB, but I have DB. I don't have CE, I have CB. So I only have one of the given pieces. Okay, they want me to solve for this. So my question is, how on earth am I going to change it? So I got to look at what I'm given and see what I can do with it. So what I noticed is that AB is made up of AD plus DB. Okay, so in my proportion it talks about AD. So if I subtract DB from both sides, that gives me the length of AD is AB minus DB. Okay, and then they give me CB, so I look at what that is, and I've got the same sort of a thing going on. CB is the entire length, and it's made up of CE plus EB. So CE is in my original, so I'm going to solve for it. And I get the length of CE is equal to CB minus EB. So if I rewrite this proportion, AD now is going to get replaced with AB minus DB over DB. Oh, that's not very good, D. Is going to be equal to, and CE is going to be replaced with CB minus EB over EB. So it's kind of like that proportion, that the other properties of proportion, part B, but instead of adding the denominator, I'm subtracting the denominator. But since I'm doing the same thing on both sides, I'm going to maintain balance. So now I'm going to start plugging in what I know. So in here they told me AB was 10, DB was 8, DB is 8. On this side, they told me CB was 7.5, but it's EB that I'm trying to solve for. All right, so I simplify, and I get 2 over 8 equals 7.5 minus EB over EB, all over EB. So I could simplify it down further and make this 1 over 4. Just leave it as 2 over 8. It really doesn't matter. I'm going to leave it as 2 over 8. And I'm going to do my cross product property, which says 2 times EB is going to be equal to 8 times that quantity. So I'm going to multiply that. So let's see, I get a 40, I get a 56, and 4 is a 60. So 60 minus 8 EB. I'm going to add 8 EB to both sides. And I get EB is equal, 10 EB is equal to 60. And then if I divide by 10, I get my final answer is EB equals 6. So we're using the idea of segment addition postulate to help us solve this problem, to create the the items that they are giving us information on. Okay, so that could be a lot of what you're doing on your homework tonight. All right, that's it.